happy people. This is Mr. Wilcox coming to you again from my kitchen table. This will be the last lesson for our second packet of virtual learning for pre-calculus. Last time we learned how to find the slope of a tangent line. Today we're going to use that process to actually find the equation. So here is what we are going to use. I'm going to pause for a second so that you can write this down in your notebook, and when you're ready, just hit play on the video again. So we're going to use our slope definition from last time, which is finding a derivative using a limit. And after we find our slope, we're going to plug in the point we're given and the slope into point slope form. And point slope form for a line is y minus y1 equals m times x minus x1. So we are going to use that to write our equation of our tangent line. All right, so here are the steps we're going to use. I'm going to pause for a second just so you can write this in your notebook, and then I will go through it. So on the next slide, we're actually going to do this example of y equals x squared plus 4x minus 12 at 220. But first, we're just going to go through the steps. So the steps, we're going to find the slope using our limit definition from last time. And then we're going to fill in our point and our slope into point slope form to make our equation of our line. So here is that example again on the slide. We're going to go through and find the equation for our tangent line. So first of all, we need to find our slope. Remember, our slope is going to be the limit as x goes to whatever our x and our point is, which is 2, of our equation minus our y over our x minus our x value. So if we simplify that, we're going to get the limit as x goes to 2 of x squared plus 14x minus 32 over x minus 2. And so if we factor that, we get the limit as x goes to 2 of x plus 16 times x minus 2 over x minus 2. So our x minus 2's cancel out. And so we just have to plug our number that we're taking our limit to and plug it in for x. So we're going to get 2 plus 16. So our slope is 18. So now that we have a point, which is our x1, y1, and we have a slope of 18, we can plug into point slope form. So we're going to have y minus your y1, which is 20. It's going to equal your slope, 18, times your x minus your x, which is 2. So this is the equation of our tangent line. All right, I have one more example for you, and then hopefully you will be ready to go. So our example is we're going to find the equation of the tangent line at the given point to f of x equals x squared plus 3x at 318. So our first thing is to find our slope. And remember, to find our slope, we're going to take the limit as x goes to our x value, 3. And then we're going to plug in our equation, so x squared plus 3x. And then our y value, which is 18, so subtract 18 and put it over x minus, again, that x value. All right. So if we go through and factor, what multiplies get negative 18 adds to get 3? Well, that would be x minus 3 times x plus 6. So our x minus 3's cancel out. And if I plug in my 3, I'm going to get 3 plus 6. So my slope is 9. So I have a slope of 9, and I have a point of 318. So when I write my equation, I'm going to have y minus my 18, because that's my original y value, is going to equal my slope, which is 9, times x minus my x value for my point, which is 3. And so the equation to my line and point slope form is y minus 18 equals 9 times the quantity x minus 3. And that is our answer for our tangent line. All right. So all you have to do is find the slope using our limit equation and then plug in the point and the slope you have into point slope form, and you'll have the equation of our tangent lines. So I hope you are all happy. I hope you're all healthy, and I hope you all have a great day.